Kia ora Year 11 and 12. Here's the last part of question 1 of last year's calculus paper. So there's a merit question and then an excellence question. Okay, the equation of a function, y equals f of x, has got the following gradient function. F dash of x is equal to 2x minus a, and a is a constant. And we're given the turning point on the graph of the function. And our mission is to figure out what is f of x. So we can get into it algebraically, but just take a step back and have a look at what we've got. This gradient function is a straight line because the equation is 2x minus a. And so we know that that's going to look something like this. And that means that my function will be a parabola. Okay, so it's always good to know where you're heading in a problem like this. So we've got f dash of x is 2x minus a. So we anti-differentiate. We're going to have x squared minus ax plus my constant of integration, so x squared minus ax plus c. Now we're going to have to use some other information in the question to help us go a bit further. And we know that this point here is a turning point. So 3, 4 is a turning point. Therefore, the gradient at that point, so f dash at 3, must equal 0. So we'll work with that now. So 0 is equal to 2 times 3 minus a. So what I'm doing there is I'm substituting into the gradient function. I'm substituting x equals 3, and we know that it must be 0 because it's a turning point. So that gives me 0 equals 6 minus a equals 6. So that's the first part done. Now we're going to use that information to figure out the equation of the function. So this is the equation of the function. I can now put in a as 6, and I'm going to do that on the next slide. Okay, so just to recap, we anti-differentiated, and that got me to this point, x squared minus ax plus c, and now we know that a must be 6, so we've got f of x is equal to x squared minus 6x plus c. Now somehow we've got to figure out what that plus c is. There's one bit of information that I haven't used completely yet, and that's that the point 3, 4 is a turning point, therefore it must be on the curve. So that means that we know that when x is 3, y is 4. So we've got 4 equals 3 squared minus 6 times 3 plus c. All right, if you need another step in there, we know that f of 3 equals 4. Right? Okay, so working with that, 4 equals 9 minus 18, negative 9 plus c. c is 13. So my equation is f of x equals x squared minus 6x plus 13. Now I'm just checking whether that was a merit question or an excellence question. That's actually an excellence question. So if you get all the way down to here, that's a T code, and if you get to here, that's a merit code. Alright, next question, also an excellence one. Find the local minimum value of the function y equals x cubed times x minus 4. Well, the first thing we're going to do is to fix up this expression by expanding out this side here. Okay, and then we're going to differentiate. To find a turning point, we set the first derivative equal to 0, and then we investigate to see what type of turning point it is. So let's get on with it. Here's y equals x to the power of 4 minus 4x cubed. My gradient function, dy by dx, equals 4x cubed minus 12x squared. And this has to equal 0 for turning point. So we're going to solve 0 equals, I'll factorise at the same time, so it's going to be 4x squared times x minus 3. Now, so 0 equals, well, nothing more I can do with that. Get rid of that. So all I've got to do now is to solve. I've got two possible values, x equals 0 or x equals 3. Now what we're looking for, I'm going to use the second derivative test here. I'm looking for the second derivative at one of these 2 points being positive, because that will give me a local minimum. Okay, so my first derivative was dy by dx equals 4x cubed minus 12x. So my second derivative is this. Now, you don't need to worry too much about which notation you use. A lot of you will be more comfortable using this notation, but this is the same thing. This is Leibniz notation, this is Newton's notation. So you use whichever of those you like. So 12x squared minus, whoops, I've lost something up there. I've lost a squared there. So 12x squared minus 24x. Now, what I'm going to do now is work out at x equals 3, what's the value of that? So at x equals 3, now we substitute 3 in there, and we get 12 times 3 squared is 9, minus 24 times 3, and that gives me 108 minus 72, which is 36. Now that's positive, so we have found that we've got a local minimum at x equals 3. But we need to make sure we've read the question. I'll just check back to the paper for what exactly are we asked to do here. Well, we're asked to find the local minimum value of the function. Now we haven't found that yet because we've just found the x value. So we need to take that x value and work out the y coordinate that goes with it. So we'll do that on a new slide. Okay, so at x equals 3, what's y? Well, y is equal to, going right back to the start, we can work with it in this form or in expanded form. So y is equal to 3 cubed times negative 1. So that's negative 27. So minimum value of the function is negative 27 when x equals 3. Okay, so that's my coordinate, right? So 3, negative 27. I'm going to do a bit more with this question that you weren't asked to do. The first thing I'm going to do is to show you the other main way that you could use to show that this is a local minimum, and that's doing this table. Now we've done this in class. So here's my x, and I'm going to look at the value of the gradient on either side. So I've identified my turning point. X value is 3. I'm going to look close to that. I'll look at 2 and 4. And all I have to do is to use my gradient function, which I'll put up here. So it's 4x cubed minus 12x squared. So the gradient function when x is 2 is 4 times 8, so that's 32, minus 12 times 4, minus 48, and that's negative 16. So we'll pop that there, and we'll just draw a line showing that it's going down the hill. We know that the gradient at 3 is 0, so it's flat here, and we evaluate the gradient on the other side. So 4 times 4 cubed, it's going to give me 256 minus 12 sixteens, so minus 192. What's that going to give me? Well, it's going to give me 256 and 8, 64. Doing this with no calculator. My brain's going a bit slowly. Right, so there we are. There's my 64 goes down here. So that's going up. So you can see that we've drawn out that we've found a local minimum. So that's quite nice. I think it's more intuitive at level 2 than doing the second derivative test, but it takes more time. And you could check what kind of turning point we've got at x equals 3, and you should find that we've got a point of inflection, okay, by doing the same kind of thing. If you've got questions about that, you can send me an email or come in and ask me. Thanks for watching. I'll put up the next question shortly.